class 10. In this topic we will be learning about accounts through which we can deposit money in a bank. Now a bank provides 4 types of accounts. You have the savings bank account, the current bank account, fixed deposit, recurring or cumulative time deposit accounts. Now the most popular services that the bank provides and that the account holders take are the savings bank account and the recurring deposit account. In savings bank account, the account holder can withdraw money and deposit money at his own convenience. But in the recurring deposit account, that is what we are going to learn in today's video, you can deposit a fixed amount every month for a fixed period of time. For example, you consider rupees 50. This is rupees 50 that you will be depositing every month, say for a fixed time period, say 1 year. That is 12 months. Now in recurring deposit account, we have what is called as maturity period. And we have maturity value. Maturity period is the total time period after which you will get the total lump sum money with the interest. So the time period, that is over here, it is considered to be as 1 year. So the total, this is the time period after which you will get a total lump sum money with the interest, that is called as the maturity period. And the amount that you are going to get after the maturity period with interest is said to be as the maturity value. Now let us learn. Let us learn to calculate the interest for a recurring deposit account. Now let us suppose say Mr. X. Okay, so let us suppose that Mr. X has opened a new account in a bank, and he has opened a recurring deposit account, wherein he is going to deposit rupees 100 every month for 6 months, and with the rate to be as 7%. Now let us calculate the interest on recurring deposit. So this is just an example. So say suppose now you have 6 months, it's going to be, let's begin from the, say if it is, he has opened an account in the month of January. It will be January, February, March, April, May and June. So in the month of Jan, say he deposits rupees 100 in the bank. So now this rupees 100 remains with the bank for 6 months. So the principal may be taken as rupees 600 for 1 month. Next he deposits rupees 100 and that remains in the bank for the remaining 5 months. So the principal may be taken as rupees 500 for that month, for another month. So next is for March, again rupees 100 he pays, that remains in the bank for 4 months, so the principal may be taken as rupees 400, and so on. So the last one he is paying rupees 100, so that will remain with the bank for that 1 month, so that will be rupees 100. So now therefore this was the principal which the bank will assume. So therefore the equivalent principal for 1 month will be the sum of everything. So you have 600 plus 500 and so on till 100. So taking out a common factor, that is 100, I am left with 6, 5, 4 and so on till 1. Now note that this 100 is the principal that Mr. X has deposited, and 6, 5, 4, 3, 2, 1 are the number of months. So now if we assume that this number of months were going on till n months, so if the months was n, then the principal, that is the equivalent principal, would have been for 1 month would be P into, this is the principal here, and it will be 1 plus 2 and so on till n terms. That is till n months. So that would be nothing but, so you have equivalent principal this is P. Now note that this is an arithmetic progression with the common difference as 1. This is the common difference throughout. So using the sum of AP, you have n divided by 2 2a plus n minus 1 times d. So that will be P into n divided by 2. So here a is 1. So 2 plus n minus 1 times d is also 1. Second term minus the first term. This is P into n divided by 2, and this will be n plus 1. So therefore this is the principal for 1 month when you are calculating interest on the recurring deposit. Now note that in recurring deposit we always consider the time period in terms of months. So therefore now when we are calculating the simple interest, that is given by PRT divided by 100. So to calculate the interest on recurring deposit, so the principal for 1 month is replaced by P into n plus 1 divided by 2, the rate divided by 100, and here since for 1 month, meaning that 1 month is taken as 1 by 12 in a year. So this is the formula for interest on recurring deposit. So in the recurring deposit, when you're calculating the formula for interest, this is the one that you'll be using. And note that P is the principal, R is the rate of interest, where N is the number of months. Okay, now after this you have to calculate the maturity value. Maturity value is nothing but the principal, that is the total money after 6 months. So that will be the total principal in that 6 months along with the interest. That will be the matured value. So using these two formulas, we will be solving examples in this topic. Okay, let us consider the first problem from exercise 2. Open your textbooks, you can pause the video and read the second problem. In the second problem, you are given that Indrajit opened a cumulative time deposit account with the Punjab National Bank, and he deposited rupees 360 per month for 2 years. So what is given here is principal, that is P is equal to rupees 360, because he is depositing it every month for how many years? 2 years. But in banking we require the number of months. So therefore N will be 2 into 12, that is converting it into months, so I will get 24 months. Let's move on. You are also given, if the rate of interest be 7% per annum, how much did he get at the time of maturity? So you are given the rate of interest to be as 7%, and you are told how much he will get after the time of maturity. How much meaning you are told to calculate the maturity value. Now note that in this topic you have to mention the units, that is rupees every time. So let us calculate the maturity value. Now for maturity value, you already have the principal, you have the number of months given. What is not known is the simple interest. So first we will calculate the simple interest. So I is equal to Pn into n plus 1 divided by 2, R divided by 100 into 1 upon 12. Substituting the values, I have 360, n is 24, and the next one is n plus 1, so that will be 25, divided by 2, R is 7 divided by 100 into 1 upon 12. So cancelling here, 12 into 2 is 24, that cancels, and 25 into 4 is 100, so 4 and 90. So 90 into 7 is equal to rupees 360. Do not forget to write the unit, that is rupees. Now once we have calculated the interest, now I can calculate the maturity value. The maturity value is Pn plus I. So P is nothing but 360 into 24 plus I is 360. So let us multiply this. So that will be equal to 8640 plus 630, which will be equal to 7, 2 and 9. Do not forget to write rupees. So the matured value after 2 years that he is going to get is rupees 9,270 when he pays rupees 360 every month. Let us consider another problem number 3, the second part. You can pause the video again and read this problem. So in this, reading the problem I have, Sajal invest rupees 600 per month for 2.5 years in a recurring deposits scheme of Oriental Bank of Commerce. So here you are given the principal. So the principal is that she has deposited every month, that is rupees 600. And the time here is that she has deposited it for 2.5 years. So 2 into 12 plus 12 into half. That will be 24 plus 6, which is equal to 30. So for 2 years it is 24 and half is 6. So that will be 24 plus 6, which is 30 months. The next thing given is, if the bank pays simple interest at 6.2 by 3. So the rate given is 6.2 by 3%. You have to calculate the amount received at the time of maturity. Again, you have to calculate the matured value. Now note that the rate here is given in terms of a mixed fraction, so convert it into an improper fraction. So 18 plus 2 will be 20 divided by 3% per annum. So now again here the maturity value is told to calculate. So first we will have to calculate the simple interest. So simple interest formula is Pn, n plus 1 divided by 2, r divided by 100 into 1 upon 12. So P is 600, n is 30 into 31 divided by 2, and the rate is 20 divided by 3 divided by 100, which when you take the reciprocal, it will be 3 into 100, so which will be 300. Okay, and this will be multiplied by 1 upon 12. So cancelling 301, and this is 2, then 5, 6, 2, and this will be 2 and 10, and this 2 and 2 will cancel. So you are left with 5 into 31 into 10, which will be 5 and 15, and then you are multiplying with 0. So it will be rupees 1,550 will be the interest. So once you have got the interest, now you calculate the matured value using the formula Pn plus I. So that will be P is 600 into 30 and I is 1550, which is 18,000 plus 1550, which is nothing but 5591 rupees. So rupees 19,550 will be the matured value that the person will get. The next question is problem number 4 from the same exercise. You can read the problem and note down what is given. So you can pause the video for a short while if you want to. So you are given that Mr. Richard has a recurring deposit account in a bank for 3 years at 7.5 per annum simple interest. So 3 years meaning n will be equal to 3 into 12, which is equal to 36 months. Next is you are given the rate, which is 7.5% per annum. Note that the next sentence, if he gets rupees 8,326.25 as interest, it means you are given here the interest, which is 8,325. They have mentioned this number and said that is as the interest, meaning that is the interest here. Then you have to find the monthly deposit and the maturity value. Monthly deposit is nothing but P, that is the principal, and the matured value. So first you have to calculate the principal. So what is given is the simple interest. So using what is given, we will first calculate the principal here. So I have the simple interest formula as Pn into n plus 1 divided by 2, R divided by 100, 1 by 12. Interest is given to be as 8325. P, that is the principal, is what you have to calculate. N is 36 into 37 divided by 2. Rate is 7.5. So I'll shift the decimal. So I have 100 into, when I'm shifting the decimal, in the denominator I'll get another 10, which when I multiply I get 1000 multiplied by 1 upon 12. So cancelling this, and this is 75 into 3, and this is by 40. So now what is remaining in the denominator, I'll take it here. I will cross multiply, or let us take another step, whichever is remaining. I have P into 9 into 37 divided by 80. So now therefore P is equal to 8325 into 80, that is this and this, divided by 9 into 37. So this will be 925, and this will be 1 and 25. So therefore P is equal to 25 into 80, which is equal to rupees 2000. Okay. So we have already calculated the principal. Now the next thing is to calculate the maturity value. The maturity value is given by Pn plus I. So what is P? We have just calculated it to be as 2000 into N, that is 36. And the interest is given to us, which is 8325. So this is 72,000 plus 8325, which will be 52308. So rupees 80,325 will be the matured value. The next problem that is considered is problem number 9. Please read it from your textbook and see what is given. You can pause the video for a while here. So you are given that Tanvi has a recurring deposit account in a finance company for 1.5 years at 9% per annum. So the number of months will be for 1.5 year, that will be 12 plus 6, which is equal to 18 months. And the rate is given to be as 9% per annum. If she gets rupees 15,426 at the time of maturity, you have to find how much per month has been invested by her. Now in the previous problem it was given that the number as interest, and here you are given the number, that is 15,426 at the time of maturity. So it means this is maturity value that is given to you, 15426. And you have to calculate per month how much he has invested. That is, principal is told to calculate. So here in problems like this, you just have to identify whether your maturity value is given or if the interest is given. If interest is given, then they'll give the number, the rupees, and they'll say as interest. If not, then they'll say this is the amount after maturity, meaning this is the matured value. So you have to calculate the principal. So you are given maturity value, so let's start with that. Maturity value is equal to Pn plus I. So substituting 15426, P you do not know, and N is 80. Again, we do not know what is I. So from here we'll obtain interest. So interest is 15426 minus 80. Okay. Now you substitute now we will be using the interest formula, and in that we will have only one unknown, that is P. So substituting, you have I is equal to Pn n plus 1 divided by 2, R divided by 100 into 1 upon 12. So substituting, 15426 minus 18p. P we do not know, but we definitely know what are the other terms here. This is 18 into 19 divided by 2. R is 9 by 100 and 1 upon 12. So cancelling here by 6, and that's it. So I have 15426 minus 18p, and this will be equal to p into 19 into 27 divided by 400, which is 15426 minus 18p, and this will be equal to 513 divided by 400p. Now take all the like terms on the other side. So I have, from here you can do it anyway. You could have cross multiplied 400 to both these terms and done it whichever way you find easier. So 426 will be equal to 513 divided by 400 minus 18 when it comes to the other side will become plus 18 and you take a common factor, that is p. So this will be 15426 is equal to 513 plus 7200 divided by 400. Therefore, P is equal to 15426 into 400 divided by, this is 3177. So dividing this by 3 twice, that is say P1 is the same, and this will be then 38 and this will be so I am left with P is equal to 1714 divided by 857 into 400. This is 1 into 2. Yes. So this will be, therefore P is equal to rupees 800. So therefore the principal over here is rupees 800. Thank you.